To carry out constructions, you're going to need a compass, protractor, and ruler in most cases. The first one we're going to look at is a perpendicular bisector. For this, you need a compass and a ruler. A perpendicular bisector is cutting the line exactly in half, such that it meets at right angles. Perpendicular means right angles, bisector means in half. The first step is to put your compass point at the end of the line. You then need to make sure that the distance between the compass is more than halfway up the line. For example, if it was here, that distance is not more than halfway of the line. So you'd extend it and make sure that you've gone beyond the halfway point. You're now going to draw an arc above and below. You could draw the full circle if you wanted, but it looks a bit messy. So instead, we'll draw an arc here, and we'll draw an arc on the other side here. You're then going to move the compass point to the other side of the line. Make sure you're being very careful. You're then also going to draw an arc from here and on the other side. Two bits that are really important to us are the points where the two arcs cross, one there and one there. You then get your ruler and join the 2 points with a straight line. The line that I've just drawn is now a perpendicular bisector. It's cut this original line exactly in half and it crosses at 90 degrees. It's very important you keep these construction lines on because the examiner needs to see what method you have used. We're now going to look at doing an angle bisector. As the name suggests, we're going to cut the angle exactly in half. To do this, we still need a compass. What you do is you put the compass point where the two lines meet. You're then going to draw an arc. One there. You could carry on over all in one motion if you wanted, or you can do it as I have done. You now have 2 points. You've got this point here and this point here. We're going to put our compass point on each one individually. Putting my compass point there, I'm going to draw an arc from there. And moving the compass point over to the other side, and draw an arc from there. Where these two final arcs meet is a very important point. If you join that together with the original point, you'll have the angle bisector. Using a ruler, join the 2 points together, and you now have the angle bisector. Just like the previous one, it's very important you leave these construction lines on because the examiner will be marking them. In this example, we're trying to find the locus of points. This is just a collection of points that, for this example, are more than 7 centimeters from S and closer to VU than UT. Let's deal with the 7 centimeters from S issue first. For this, we're going to use a ruler and a compass. If you get a ruler and then a compass, measure the compass so that it's 7 centimeters apart. Now that you have your compass 7 centimeters apart, you can put your point at where S is. From here, if you draw a circle, all the points on the circle will be 7 centimeters from S. Now we don't need to draw the full circle, we can just draw the bit that we need. Anywhere on this arc is 7 centimeters from S. Anywhere on this side is going to be closer than 7 centimeters from S, and anywhere on this right hand side will be more than 7 centimeters from S. So this is the area that we're currently looking at. We also want to be closer to VU than UT. VU is this line here, and UT is this line here. This goes back to an angle bisector, what we looked at earlier. If you can find the angle bisector of these two lines, you'll find the middle of VU and UT. You can then pick the side that's closer to VU. So let's have a go. To do our angle bisector, we're going to put the compass point where U is. If we now draw an arc, now that we have these 2 points, we're going to draw more arcs from there. And from the other side. The point that they intersect, that's the point that we want. If we now draw a straight line from this point and U, so from U to that point there, that's the angle bisector of VU and UT. Anywhere on this line is exactly halfway between VU and UT. However, we want closer to VU, which means we want it on this side. So all the points that are closer to VU are on this side of the line, the left-hand side or underneath. And we also want the points that are more than 7 centimeters from S, which are on the right-hand side of this arc. So all the points that we want are within this bit here. So this region here is a loci that satisfies both those things.